So the main difference between these two types of feedback is simply the source of the hormone. So the source of the short feedback loop is going to be from the anterior pituitary itself, whereas the source of the long loop negative feedback is going to be from the target gland, which is secreting that third hormone. So outside of that, there's really no fundamental difference between what the hormone is doing. It's just that the levels of this hormone is being communicated to the hypothalamus, and then the hypothalamus will determine, based upon those levels, whether or not it needs to secrete more or less of that tropic hormone 1. So the only difference is the source of the hormone that is being relayed or communicated back to the hypothalamus, and the effect is kind of the same. If we have excess of this hormone, it's going to tell the hypothalamus to slow down secretion of that first tropic hormone. If we have less of that hormone, it's going to tell the hypothalamus to secrete more of that first tropic hormone. Another difference may be the time that it takes. So because the endocrine glands are kind of more dispersed throughout the body, it may take a longer time for this hormone to feed back to the hypothalamus than for the anterior pituitary hormone to feed back to the hypothalamus. This can also just be the distance of how far they are apart as well, okay? All right, that was a good question. So let's move on here to packet 2. And this is really going to go into the specifics of the various hormones themselves. So we're going to start by looking at the synthesis and secretion of thyroid hormones, and then we're going to distinguish between the direct and permissive actions of thyroid hormone. So hormones that are released by the thyroid gland are 2 types. We've got the T4, which is tetraiodothyronine, also called thyroxine, and then T3, which is triiodothyronine. And the function of thyroid hormone in general is to regulate our metabolism, okay? It's gonna help to speed up cellular metabolism, speed up skeletal muscle metabolism, speed up things like the heart rate and the breathing rate, and just the metabolic energy or the metabolic expenditure of our cells. And this is why when someone has hyperthyroidism or they have an overactive thyroid gland, they are typically very energetic, right? They usually have lots of energy, they usually have lots of sweating. They're typically very hot. They typically lose weight as a first sign or symptom of overactive thyroid. Sometimes they get headaches, but just general functions or general changes that are aligned with an increase in metabolic activity. And that's also true for hypothyroid patients. So patients that have underactive thyroid typically have the symptoms or signs on the opposite end of that spectrum. They're typically slow or tired or a bit more sluggish. They typically have weight gain as an initial sign or symptom for an underactive thyroid. So that can tell us a little bit about the function of the thyroid gland. It's controlling or regulating our level of metabolism. Okay. There's also another hormone that is released from the thyroid gland, and this is called calcitonin. And calcitonin helps to regulate our calcium levels in the blood. It's going to decrease our calcium quantities in the blood by helping the bones to decrease their production of calcium and helping that calcium to be mobilized into our cells and be used instead of being at high levels in the blood. So it's going to decrease our blood calcium level, which is going to help to regulate and prevent excess calcium in the blood. Okay, we don't want to have a little calcium, but we also don't want to have excess calcium circulating in our blood. Okay. Let's talk a little bit about the anatomy of where the thyroid is located. So as I mentioned earlier, it's located anterior to the trachea. So in the neck region or the laryngeal region here, it's going to have two sides or two glands, two lobes rather, sorry, on either side. And then it's going to have these glandular appearance, and then inside of this, we're going to talk about the functional unit, which is called a follicle. So we can see this kind of bulged appearance of the thyroid gland, and this is how most of our glands appear, as repeating units of these smaller functional units. Okay. All right, so this is what the thyroid gland looks like on a histological view. And the functional unit of the thyroid gland is called a follicle, a thyroid follicle. And these follicles are lined by these follicular cells. And inside of the follicles, we have this material, this substance that's called colloid. Now, colloid is simply the storage of what becomes the thyroid hormone. So this is where we synthesize our thyroid hormones, T3 and T4, and they are stored in this colloid, this material or this substance that's inside the follicle, and it's stored here until it's ready to be secreted. And so we have thyroglobulin, which is a protein. This is the precursor for thyroid hormone. It's also located here in the colloid. And so upon the instruction that's coming from the anterior pituitary, the follicle that is being lined by these follicular cells will then take this colloid. This colloid will be absorbed into these follicular cells. It's going to make this active form from thyroglobulin. It's going to require iodide, which is the ionized form of iodine, and actively transport that thyroglobulin from the blood. It's going to transport that thyroglobulin from the colloid, which is inactivated, out into the blood, which is the activated form of these thyroid hormones. So basically, we've got colloid, which is made of thyroglobulin as the storage form of thyroid hormone. And then we need iodide in order to activate that thyroglobulin. And then that can be released into the blood as thyroid hormone in its activated form. Now, two important correlations here. One is that this is the importance of iodine in our diet, right? Iodine that comes in from table salt or seafood or leafy vegetables is really important to the production of thyroid hormone. And so if we lack iodine coming in from our diet, then we typically fall short of thyroid hormone. So this is another important mineral that can be that can result in hypothyroidism if we are deficient in this mineral. Okay, and this is why we have to have this in our diet. Another important correlation here is colloid. So when we don't have iodine in our diet, and when we do have this hypothyroidism, this underactive thyroid gland, this colloid begins to build up. Remember I said this colloid is the storage form of thyroid hormone. So if we're not actively converting this thyroglobulin, which is being stored as colloid, if we're not actively converting that to thyroid hormone, it starts to build up and build up and build up. And these this colloid inside of the follicles begin to get bigger, the follicles begin to get bigger, and that's what we call a goiter. So a goiter, many of you may have seen a goiter, but it's pretty much a swelling of the thyroid gland as all of that colloid starts to build up because we're not converting it to thyroid hormone and circulating it throughout the body. Okay, so two kind of important clinical correlations of colloid and iodide in terms of the thyroid function.